Welcome to Rocket Propulsion Class Lecture 1. History and Evolution of Rockets. By Vinod Kumar Annamalai, Assistant Professor. Department of Aerospace Engineering. SRM Institute of Science and Technology. Archytas, 428 to 347 BC. Archytas, a Greek philosopher, mathematician, and astronomer, was said to have constructed and flown a small bird-shaped device that was propelled by a jet of steam or compressed air. The bird may have been suspended by a wire or mounted at the end of a bar that revolved around some sort of pivot. This was the first reported device to use rocket propulsion. Hero engine, CAD 10 to 70, though not a rocket, the main principle behind rocket and jet propulsion was employed in a steam engine invented by Hero of Alexandria. The exact appearance of Hero's engine is not known, but it consisted of some sort of copper vessel heated by a fire beneath. Water in the vessel turned into steam and traveled up two tubes to a hollow sphere that was free to rotate. Two L-shaped tubes from the sphere allowed the steam to escape in jets of gas. The sphere rotated rapidly in the opposite direction of the jets. The Hero engine was seen as an amusing toy, and its potential was not realized for 1,000 years. Chinese fire arrows, AD 1232. The origins of gunpowder are not clear, but the Chinese reportedly had a rudimentary form of it in the 1st century. A mixture of saltpeter, sulfur, and charcoal dust produced colorful sparks and smoke when ignited. The powder was used to make fireworks. Tubes of bamboo and leather, closed off at one end, were packed with gunpowder. Depending upon how the powder was packed and the size of the opening, a fountain of sparks or a bang would result when the powder was ignited. It is likely that some fireworks skittered about because of the thrust produced from the gases escaping the open end. Thus the rocket was born. By 1232, these primitive rockets were attached to arrows and used to repel Mongol invaders in the Battle of Kaikeng. Next, Roger Bacon, c. 1214 to c. 1292. A monk, Bacon wrote about gunpowder in his De Epistola Fratris Arbacanus, De Secretis Aperibus Artis et Naturis et Nullitate Magia. We can, with saltpeter and other substances, compose artificially a fire that can be launched over long distances. By only using a very small quantity of this material, much light can be created accompanied by a horrible fracas. It is possible with it to destroy a town or an army. Bacon is thought to have developed improved gunpowder formulas that greatly increased the mixture's power. Huan Hu, 16th century. According to legend, Huan Hu, a Chinese stargazer and local official living sometime around the middle of the Ming dynasty, dreamed of spaceflight. He constructed a chair and attached 47 gunpowder rockets to its base. In some versions of the story, his chair also had kite wings. On launch day, 47 assistants rushed up and simultaneously lit the fuses of all the rockets. A huge explosion followed. When the smoke cleared, Huan Hu was gone. Some have suggested Huan Hu actually made it into space, and you can see him as the man in the moon. Regardless of the actual end, Huan Hu had the right idea, used rockets to travel into space. Next, history as rockets go to war. For centuries to come, rockets competed with cannons as the weapon of choice for war. Each technological development moved one or the other system into or out of favor. Cannons were more accurate. Rockets could be fired more quickly. BRAECH loading cannons speeded up the firing. Rocket fins increased accuracy. Cannons had greater range. Rockets had greater range. And so on. Invention abounded. Invented by Joannes de Fontana of Italy, 1420, a surface-running rocket torpedo was supposed to set enemy ships on fire. Kazimierz Siemianowicz, c. 1600 to c. 1651. Kazimierz Siemianowicz, a Polish-Lithuanian commander in the Polish Royal Artillery, was an expert in the fields of artillery and rocketry. He wrote a manuscript on rocketry that was partially published before his death. In Artis Magnae Artillerie Pars Prima, he published a design for multi-stage rockets that was to become a fundamental rocket technology for rockets heading for outer space. Siemianowicz also proposed batteries for military rocket launching and delta wing stabilizers to replace the guiding rods currently in use with military rockets. It was rumored that Siemianowicz was killed by members of guilds that were opposed to him publishing their secrets, and they hid or destroyed the remaining parts of his manuscript. The birth of rocket science. Galileo Galilei, 1564 to 1642. In addition to his many other accomplishments, this Italian astronomer and mathematician rekindled the spirit of scientific experimentation and challenged old beliefs relating to mass and gravity. He proved that an object in motion does not need the continuous application of force to keep moving. He called this property of matter, which causes it to resist changes in velocity, inertia. Inertia is one of the fundamental properties that Isaac Newton would later incorporate into his laws of motion. Newton's laws of motion, 1642–1727. English scientist Sir Isaac Newton condensed all rocket science into 3 elegant scientific laws. Published in Philosophiae Naturalis Principia Mathematica, his laws, previously understood intuitively by early rocketeers, provided the foundation for all modern rocket science. The Rocket Principles chapter focuses on these laws, and the Practical Rocketry chapter demonstrates the applications of these laws. Colonel William Congreve, 1772–1828. Following stunning rocket barrages against the British by the forces of Tipu Sultan of India, William Congreve took charge of British military rocket companies. Some of his designs had operational ranges of 6,000 yards. He created both case-shot rockets that sprayed the enemy with carbine balls and incendiary rockets for burning ships and buildings. He invented launching rockets from ships. The phrase "by the rocket's red glare," coined by Francis Scott Key during the War of 1812, referred to British-launched Congreve rockets. Modern rocket pioneers. Konstantin Tsiolkovsky, 1857–1935. Konstantin Tsiolkovsky was a teacher, theorist, and astronautics pioneer. Son of a Polish forester who emigrated to Russia, he wrote and taught extensively about human space travel and is considered the father of cosmonautics and human spaceflight. Tsiolkovsky advocated liquid propellant rocket engines, orbital space stations, solar energy, and colonization of the solar system. His most famous work, Research into Interplanetary Space by Means of Rocket Power, was published in 1903, the same year the Wright brothers achieved powered and controlled airplane flight. His rocket equation, based on Newton's second law of motion, relates rocket engine exhaust velocity to the change in velocity of the vehicle itself. Robert H. Goddard, 1882–1945. American college professor and scientist Robert Goddard built and flew the world's first liquid propellant rocket on March 16, 1926. Its flight, though unimpressive, it climbed only 12.5 meters, was the forerunner of the Saturn V moon rocket 43 years later. At the request of local townsfolk, Goddard moved his experiments from Auburn, Massachusetts, to the deserts around Roswell, New Mexico. There he continued his experiments and developed a gyroscope system to control his rockets in flight, instrumentation payload compartments, and parachute recovery systems. He is often referred to as the father of modern rocketry. Hermann Oberth, 1894–1989. Hermann Oberth, a Romanian by birth and a naturalized German citizen, became fascinated by the works of Jules Verne and devoted his life to promoting space travel. His dissertation for the University of Heidelberg, rejected for being too speculative, became the basis for his book Die Rakete zu den Planeten, By Rocket to Space. The book explained the mathematics of spaceflight and proposed practical rocket designs and space stations. This and other books inspired a generation of rocketeers. Rocket societies sprang up around the world, including the German Verein für Raumschifffahrt, Society for Space Travel, that led to the development of the V2 rocket. Rocket experimenters, early 20th century. In the 1920s and 1930s, leading up to World War II, amateur rocketeers and scientists worldwide attempted to use rockets on airplanes, racing cars, boats, bicycles with wings, throw lines for rescuing sailors from sinking ships, mail delivery vehicles for offshore islands, and anything else they could dream up. Though there were many failures, experience taught the experimenters how to make their rockets more powerful and more reliable. During World War II, flying bombs. The necessities of war led to massive technological improvements in aeronautics and rocketry. Almost overnight, rockets graduated from novelties and dream flying machines to sophisticated weapons of destruction. Rockets propelled nearly unstoppable German fighter planes and Japanese kamikaze pilots with bombs into ships. War would never be the same again. Virgil Tungswift V2. In the late 1930s, the German Verein für Raumschifffahrt Society for Space Travel evolved into the team that built and flew the most advanced rocket for the time, the V2. On the shores of the Baltic Sea, the team, under the directorship of Wernher von Braun, created a rocket powered by alcohol and liquid oxygen. With a range of 200 miles and a maximum altitude of 55 miles, the V2 could deliver a 1-ton explosive warhead to the heart of London without warning. Thousands of V2s were built, but they entered the war too late to affect the outcome. Explorer 1. The United States entered the satellite launching business on January 31, 1958 with the successful launch of Explorer 1. The satellite was launched atop the Juno 1, a modified Jupiter C booster. Though much smaller than the Sputniks, only 13.93 kilograms, 30.66 pounds, Explorer 1's Geiger counter made the first important discovery about the space environment. Explorer 1 detected around Earth what would later be called the Van Allen radiation belts. X-15. Between 1959 and 1968, the X-15 experimental aircraft flew to the edge of space. In 199 flights, the air-launched rocket plane broke many flight records, including speed, 7,274 kph, or 4,520 miles per hour, and altitude records, 108 kilometers or 67 miles. Test flights established important parameters for attitude control in space and re-entry angles. Neil Armstrong, the first American to step on the moon, was one of 12 X-15 pilots. Yuri Gagarin goes into orbit. On April 12, 1961, space became the domain of humans with the launch of cosmonaut Yuri Gagarin. His SPACE flight lasted 1 hour and 48 minutes. During that time, Gagarin orbited Earth one time inside his Vostok 1 space capsule, reaching a maximum altitude of 315 kilometers, 196 miles. Upon re-entry, Gagarin ejected himself from the capsule at an altitude of 6,100 meters, 20,000 feet, and parachuted safely to the ground. Freedom 7. On May 5, 1961, American astronaut Alan Shepard Jr. lifted off from Cape Canaveral, Florida, inside his Freedom 7 Mercury space capsule, which sat atop a Redstone rocket. The rocket did not have enough power to send the craft into orbit, and Shepard made a suborbital flight reaching 187 kilometers, 116 miles, before his capsule returned to Earth in an ocean splashdown 15 minutes 22 seconds later. Moon rocket. Just days after Alan Shepard's flight, President John F. Kennedy addressed a joint session of Congress and challenged America to send an American to the moon and returned him safely before the end of the decade. Although it was a shockingly bold announcement, some of the steps to accomplish this mission were already underway. NASA had begun work on components of a rocket capable of a round-trip lunar flight. By the next year, the rocket was named the Saturn V. It would be 110.6 meters, or 363 feet tall, dwarfing all previous rockets. The Saturn V would consist of 3 stages, a capsule with a small propulsion unit for the return trip, and a 2-stage lunar lander. Glenn orbits Earth. On February 20, 1962, riding on a more powerful missile, the Atlas, astronaut John H. Glenn Jr. became the first American to go into orbit. Glenn's flight achieved parity with the Soviet program. Glenn orbited Earth 3 times for a total of 4 hours and 55 minutes in space. A sensor switch led to an early return. The sensor indicated that the Mercury capsule heat shield was loose, but the shield was later determined to be firmly in place during flight. The sensor was faulty. The last of the 6 Mercury flights took place on May 15, 1963, with astronaut Gordon Cooper remaining in space for nearly a day and a half. Preparing for the moon. Project Gemini followed the Mercury missions. The Gemini space capsule, riding on top of a Titan missile, contained 2 astronauts. During missions lasting up to 14 days, Gemini astronauts pioneered spacewalking, spacecraft rendezvous, and docking procedures. Important spacecraft systems, needed for the coming moon flights, were evaluated. 10 Gemini missions were flown during 1965 and 1966. The Titan rocket, initially created as an intercontinental ballistic missile, went on to carry the Viking spacecraft to Mars and the Voyager spacecraft to the outer solar system in the 1970s. Dr. Wernher von Braun. One of the leading figures in the development of pre-war Germany's rocket program and the development of the V-2 missile, von Braun, 1912 to 1977, became a leading proponent of America's space program. He entered the United States after the war and became a naturalized citizen. He worked on the development of intercontinental ballistic missiles and led the development team that launched Explorer 1. Dr. von Braun was the chief architect and engineer of the Saturn V moon rocket. His popular writings and collaboration with Disney on a Tomorrowland TV series did much to inspire the next generation of rocket scientists and astronauts. Gene Roddenberry. Gene Roddenberry, 1921–1991, a distinguished World War II bomber pilot and commercial pilot, began his writing career penning stories about flying. He began writing for television and developed a concept for a Western series set among the stars. For 3 years, 1966–1968, the Star Trek series explored a wide range of scientific and social issues as humans traveled across the galaxy. The series became so popular that the first Space Shuttle orbiter test vehicle was named Enterprise after the starship Enterprise. The original show spawned several companion series and a string of movies. Roddenberry, a visionary, inspired a generation of space travelers. One small step. At 10:56 p.m. EDT, July 20, 1969, American astronaut Neil Armstrong set foot on the moon. It was the first time in history that humans had touched another world. He was followed to the surface by Edwin Buzz Aldrin Jr. A third astronaut, Michael Collins, remained in lunar orbit in the Apollo capsule. The Apollo 11 mission was the first of 6 moon landings extending to the end of 1972. The astronauts' spacecraft, the lunar module, consisted of a descent and an ascent stage. The descent stage had 4 legs and a powerful rocket engine to slow the craft for landing on the moon. After surface explorations, the upper part of the lander lifted off, using its own rocket engine, and rendezvoused with the Apollo capsule for the return to Earth. Skylab. Using a modified third stage of the Saturn V rocket, the United States finally launched its first space station, called Skylab, into Earth orbit in 1973. Rather than engines and fuel tanks, the interior of the third stage was fitted with living quarters and laboratories for 3 astronauts on extended stays in space. Solar panels provided electric power. Due to a problem during launch, one of the large panels was lost. Nevertheless, 3 crews of astronauts called Skylab home until 1974. The last crew remained in space 84 days. Smaller Saturn. The Saturn V rocket was capable of launching 117,900 kilograms, 260,000 pounds, into low Earth orbit, and 40,800 kilograms, 90,000 pounds, to the moon. For some Apollo missions, though, a smaller Saturn was called for. The Saturn IB was 68 meters, 224 feet, tall and required a scaffold platform nicknamed the Milk Stool to be placed on the pad designed for Saturn V rockets. This enabled the Saturn IB to match up with swing arms from the launch structure. The Saturn IB carried some of the early Apollo test missions, the 3 crews for Skylab, and the American crew for the 1975 historic Apollo-Soyuz mission, linking astronauts and cosmonauts in orbit. Orbits and probes. Deep space. The Titan rockets, 1959–2005, used for launching the Gemini missions, found wide use in launching unmanned payloads. Upgraded versions of Titan's lofted heavy satellites into Earth orbit and propelled important spacecraft to other planets. The Viking missions to Mars and the Voyager missions to the outer planets and interstellar space are among its credits. Sounding rockets. Although rockets have generally gotten larger and more powerful, there are many reasons for flying smaller rockets. The Canadian-designed Black Brant sounding rocket has been flying since 1961 and has successfully completed over 800 flights carrying small payloads such as cameras, instruments, and microgravity experiments. The Black Brant's reliability and low cost has made it a favorite of researchers. The biggest multi-stage Black Brants have payload capacities of about 100 kilograms, 220 pounds, and can reach altitudes of up to 900 kilometers, 560 miles. Delta family. With roots going back to the early 1960s, the American Delta rocket is one of the most versatile of the commercial and military payload launch rockets. Delta has many configurations, including multiple stages and heavy lift strap-on boosters that increase payload capacity to high orbits. The Delta family has logged more than 325 launches, with a success rate exceeding 95%. Atlas. Like the Delta rocket, the Atlas has deep roots. Now in its 5th major configuration, the Atlas was created as a missile in the 1950s. It was adapted to carry John Glenn and 3 other Mercury astronauts to space and has since been used for many commercial, scientific, and military satellite launches and interplanetary missions. The Atlas V rocket, shown, is the latest in the series. Pegasus. Like the mythological creature, the Pegasus launch vehicle is winged. Lifted to about 12,000 meters, it is then air-launched from under the wing of a carrier aircraft. This arrangement keeps launch costs low for small orbital payloads. 30 years. The Space Shuttle was a new concept for carrying crews and payloads into low Earth orbit. It consisted of a central external tank surrounded by 2 solid rocket boosters and a winged orbiter. Only the orbiter, a spacecraft airplane space truck, actually reached orbit. It was designed to be reusable, as were the solid rocket boosters. A new external tank was needed for each mission. Inside a cavernous payload bay were science laboratories, space probes, telescopes, or Earth sensing systems. Many shuttle payloads consisted of components for the International Space Station. At the end of a shuttle mission, the orbiter re-entered Earth's atmosphere and glided to an unpowered landing on a runway. The first space shuttle flight took place in 1981, and the last of its 135 missions concluded in 2011. The Space Launch System and a new era of commercial spaceflight. The Space Launch System. A new and different kind of rocket is needed as NASA prepares to extend its mission beyond low Earth orbit and out into the solar system. The Space Launch System, SLS, will be used for Earth orbital flights and long-range missions to places like asteroids or Mars and its moons. The SLS rocket will be the most powerful launch vehicle in history, and it is being developed in 2 phases. Heritage hardware, components from previous rockets, is being used to build a heavy-lift rocket for development testing from 2017 to 2021. It will lift up to 70 metric tons of payload. This rocket will make 2 lunar flybys carrying an Orion spacecraft, the second with a crew. The advanced SLS rocket will lift up to 130 metric tons, including equipment, cargo, scientific experiments, and/or the Orion spacecraft into deep space. The Dragon and the Falcon. The Dragon is the first orbital spacecraft launched and recovered by a private company. As one of several private endeavors under NASA's Commercial Orbital Transportation Services program, Dragon was developed by Space Exploration Technologies, or SpaceX. It is an autonomous spacecraft that will deliver to and return payloads and crew from the International Space Station. It will ride on Falcon rockets also built by SpaceX. The Falcon is a family of rockets to meet different mission requirements. The Falcon Heavy is expected to be able to lift 53,000 kilograms to low Earth orbit, making it the most powerful U.S. rocket after NASA's SLS rockets. Dream Chaser. Sierra Nevada Corporation is working with NASA to develop a commercial spacecraft for transporting crew and cargo to and from the ISS. At first look, the spacecraft, called the Dream Chaser, appears to be a small space shuttle, but it is really a lifting body. Its shape is based on NASA's HL-20. Lifting bodies are aircraft with minimal or no wings that get their lift from the shape of their fuselage. Shaped something like a boat, the Dream Chaser will be launched at the top of a rocket in place of a nose cone, carry up to 7 people to the ISS, and will land back on Earth as an airplane. Dream Chaser is expected to be a safe, reliable, and cost-effective way of transporting crew to low Earth orbit. Space tourism. On October 4, 2004, Spaceshipin became the first private space vehicle to climb above an altitude of 100 kilometers, 62 miles, twice in a 14-day period. Air-launched by a mothership, Spaceshipin crossed the acknowledged boundary of Earth's atmosphere in space. Virgin Galactic is offering suborbital flights to tourists and to researchers. Spaceshipin flights will originate from Spaceport America, located in southern New Mexico. Soon, Spaceflight will belong to all